All right, everyone say hi to Amy.
Hi, Amy.
We're going to ask her if she's really sick or she's sleeping in, right? What do you want to say, Ebony? Confront her. Okay, here we go. If the limit as x approaches infinity of a function, let's call it f of x, value, let's call it b, or the limit as x approaches negative infinity of some function, in this case the same function as prior, whatever b is, 5, okay, then you have an HA, which is horizontal asymptotes, at y equals to b. Okay, so let's talk about this really quickly. What does a horizontal asymptote look like? I remember what it looks like. Like this, right? Remember we use a dash line to represent it and represent what it can be? Do you guys agree with that? All right, so for our calculus definition, you're going to have a horizontal asymptote if and only if you do the limits, either positive infinity or negative infinity. If it comes out to be like a value, like 0, like -5, like 6, then immediately you're going to have a what? Yeah, an HA, a horizontal asymptote. Can you have more than one? Yeah. What if this comes out to be 0 and this is like -5? Then guess what? How many HAs would you have? 2. Because this is an or. Or means either one can be true or both. Okay. So you may have more than one, or you don't have to have any at all. Okay. All right. Use your graphing calculator. Here we go. For the function f of x, so graph this in your calculator for me. Change your calculator to radians if it's not already radians. Make your window maybe from -10 to +10 once it's in radians. And then what does it look like? Make sure it's in radians, okay? If you choose to do it in degrees, then just make it a lot bigger, because 360 degrees is 2 pi radians. Okay, so graph it out. Hit graph. What does it look like once you enter in the function? Y equals, y equals. Clear that out. Okay. Once you do from -10 to 10, can you hit zoom fit to see if it gives you a nice graph? Does it give you a nice graph? Is it oscillating? Whoa, what does that look like? Let me see the equation. Okay, is it oscillating? Yeah. Perfect. Looking good. Oh, I do. Yeah. I don't know. Go all the way down to zoom fit. Yes. Where did it go? I don't know. Let's see your window. Okay, hit zoom. 0. What you doing, Jack? I didn't do anything. Oh. You have no idea why I asked this. That's super interesting.
Maybe it's just like we're surprised that I gotta stay out.
Okay. Question number 1. I'm going to add on a little bit before I go to question number 1. What's that one special rule that I gave you in the previous video notes? Limit as x approaches 0 of sine of x over x. What's the answer?
1.
Perfect. Okay. Now, as you can see, it's not sine of x, right? What if I add on? Let's call it c. Limit as x approaches 0 of sine of 2x over x. Look at your calculator for me. What did the calculator say? What's the height? Look at your calculator. Look at your calculator. It's already on your screen. Yeah. As x approaches 0, would you agree the calculator said is 2? Okay? Now, based on that pattern, I'm going to add a letter D. Limit as x approaches 0, bless you, sine of, let's use a variable nx over x. What do you think the answer is? It would be 10. Okay, only if it approaches 0. But in our note today, we're dealing with infinity. So, all right. Can you find a button that says window for me? Okay, I want you to hit second window. Second one. Can you go to the triangle? Okay. Hit second window. Find the button that says window. Hit second window. Can you see there's a delta table? Yeah. Hit 100. Okay. And then go hit second graph. Second graph. Whoa. Okay, what we did was we changed your table to a lot bigger, right? So, because I'm interested in approaching pos infinity, and for me to get there quick, I don't want it an increment of 1. So look at your table. As you're getting to 1,000 and like 2,000, what's happening to the height? Closer and closer to 0. So this is equal to what, based on your table? 0. That's right. Okay. So we can use your calculator to get the answer pretty quickly. This is 0. Okay. Now go up to go the negative 1,000. What's happening? Calculator said. So as you're going up to get to negative 1,000, what's the calculator say? Big value or small value? Yeah. Small. How small? Really small. Closer and closer to what? 0. So that's right. As you can see, the limit as x approaches negative infinity and pos infinity are both 0. Would you have an HA? What's your HA? Therefore, y equals to 0. If you don't have a y equal, you can't get any credit, like 0 credit. So make sure y equals. By the way, 3 dots means what? Therefore, as a result, hence, okay? For what? Hit second table, second graph. Okay, so find 1,000 as x approaches 1,000. What's happening to the y value? Yep, close to what? Perfect. Okay. All right, here we go. Let's do 2. Can you plug in 2 for me in your calculator? Here's 2. Let's do it with a calculator first, just in case I'm nice enough to put this on a calculator test. And you don't have to do that in break. Okay. What's the limit as x approaches positive infinity and negative infinity? Let's do positive infinity first. So that's the first one. Once you put it in, just go to second table. You already have a table. That's right. You can also hit zoom fit to see what the graph looks like. Yeah. Make sure the equation is entered in front of you. What is this still an oscillating graph? Yeah. By the way, if you have an older calculator, should you guys put quantity on the numerator? Yeah. All of it? Yeah. Make sure that's okay. Whoa. Yeah, okay. So it looks like this, right guys? Oscillating still? Oh, let's take your parentheses. Like that, about, okay. So, question number 1. As x approaches infinity, look at your table. What's y approaching? Look at your table. As x approaches infinity, like 1,000, like 2,000. What's y approaching?
2.
Is it 2? Yeah, it's 2. Now, would it be the same for x approaches negative infinity? Go to the table, go to negative 2,000 value. Is it not negative 2 or still 2? Still 2, okay, so I have the answer right away. But then we can verify that using algebra. Here we go. Algebraic work. We're going to do the positive infinity first. Limit as x approaches positive infinity of your function, 2x plus sine of x all over x. If this is on a non-calculator part and you have to do it algebraically, how would you proceed? Separate them? Very good. Well said. This is limit as x approaches infinity of 2x over x plus limit of x approaches infinity sine x over x. Is that okay? Okay, now what? Yep, the x's will cancel. So what's the answer to that one? That's immediately 2. You're right. Plus. How about the right side? Sine of x over x, x approaches infinity.
1.
Is it 1? Oh, I thought that's when x approaches 0. So what's this answer?
0.
How do you know?
I don't.
How do you know? So you're guessing.
0. No, it's algebra 1. 2 plus.
Okay, now the answer is actually 0, and here's why. You have to understand the why more than anything, because let's pick, remember, we're looking for the output, right? Like where the height it's kind of getting to. Okay. So if x is approaching something ginormous, like 1,000, is that okay?
Yes.
Question number 1, this is 1,000 on the top. What is the biggest output sine of x can have?
1.
1. Yes or no? What's the smallest value the sine of x can have?
0. Oh.
Remember the curve of sine. How high does it go and how low does it go?
-1.
-1. Okay, so you can take 1 divided by 1,000 or 10,000. You can take -1 divided by 10,000. Either way, what is it approaching? Closer and closer to 0. It may be a little bit of a negative or positive depending on where it ends, but it's still getting closer and closer to 0. So that's why this is 0. So that limit is right. It's 0 based on our guess and our educated guess. Okay, so that's 2 total. How about the right side? As limit approaches negative infinity. Can I start with the breaking it up right away? Sure, okay. So this is really the limit as 2x divided by x plus limit as x approaches negative infinity of sine x over x, okay? Similarly, this guy is still what? It's still 2. Now how about limit as x approaches negative infinity of sine x over x?
0.
Is it still 0? Yeah, okay, because 1 or -1 divided by -10,000 or -1 million is still creeping closer and closer to what? 0. So they're both what? 2. Okay. Now it didn't ask in this function, guys, if I say, well, what's the HA? Would you be able to find me the HA? If I extend it further and said, what's the HA? What would you say? Y equals to 2. Okay. It didn't ask in here, but just in case I do ask. Okay. HA. All right. Now next we have properties for limits as it approaches positive or negative infinity. And just so you are aware, the property are all the same as the previous one. Okay, so I'm just going to copy it over. So you're going to have the sum And just like what you just saw, bless you, you can break that up. So the limit as x approaches either positive or negative infinity of two functions adding together, I can simply take them apart, okay, if it's easier to find the limits independently and then add them later. Sometimes it is easier to break them up and sometimes it isn't, okay? But we want the tools to know what's good for us. So that's the sum. Same thing with the difference. If you have two functions subtracting one another, you can also break those guys up. So limit as x approaches positive or negative infinity of f of x minus g of x is the same thing as saying limit as x approaches positive or negative infinity of f of x, bless you, minus limit as x approaches positive and negative infinity g of x. Oh, it went. Okay. And then we have the product, same rules. So if we have two functions multiplying together, like f of x times g of x, I can find them independently and then do what at the end? And multiply. You're right. Constant multiple, same rule as before. Am I writing too fast?
So are all these rules the same as if it was like a definite value instead of positive?
Correct. With non-infinity. Correct. You said it very well. So if you have a k value times one of the functions, let's pick f of x, then it's the same thing as taking the k out, find the limits, okay, and then multiply it at the end. Two more, you have the quotient and your power. So you have the limit as x approaches either positive or negative infinity of f of x divided by g of x. I can independently find them first and then divide. Then the last one's your power. So the limit as x approaches positive or negative infinity, what if you have f of x raised to a power of p? Technically, you can find the limits first and then raise that to a power of p. So limit as x approaches plus or minus infinity of f of x first. So Ryan said same before, so you don't have to worry about it. On the next one, do you guys want to do calculator first or algebraic first? Calculator first, you see what the answer first? So example 3, if you have it printed notes already, go ahead and punch in your calculator. Let me know what the answer is. And then we'll go back and do it by hand. Make sure you know how to punch it in the calculator correctly, okay? Should you put, if you have an older calculator that doesn't have a fraction bar, should you put quantity in the numerator? So we are interested in finding the limits, okay, of positive infinity and the limits of negative infinity. Okay, find the answer to both. We'll come back together and do it algebraically.
What?
If you have like a funky looking graph, can you like talk to your friend? If the three of you aren't matching, or the two of you aren't matching, that means somebody's doing something wrong.
Wait, let me see. Check one. Wait,
Let me see you. X. X times sine of x plus 2 sine of x all over 2x squared. 1, 2, 3. Let me see what plus you and t, right? Interesting. Something. Well, we're getting closer to. Yeah, what is that? Look at your table, guys. What is it getting closer and closer to?
Zero.
Zero? It's weird. Some of you have this, and some of you have something that's oscillating. So, who's right? What should you have? I don't know. I'm going to ask my Desmos. Let's see what Desmos says. Someone give me the numerator. What was the numerator?
2x squared.
Okay.
Shoot.
What is it? X. X times sine x. Close it. Okay. Plus. Oh, hold on. I'm going to move this guy out. Plus 2 function sine x. Okay. All of it divided by. Oh, no, the whole thing, don't I? Dang it. Go back. Back. No, it doesn't allow me. No. There. I need to do another quantity, don't I? Because it's not allowing me to. There you go. Okay, now divided by all over 2x. X squared? X squared. All right, that's what I got. Who's right? Okay. So I'm going to pinch this in. As you can see, as x is getting closer and closer to positive infinity, can you see that red line? Is getting very, very close to what? 0. Similarly to the right side, okay, the red line is getting very, 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 very close to 0. So our answer is 0. Now, how do we do it algebraically? Let's do it. Okay, so limits as x approaches positive infinity of x times sine of x plus 2 times sine of x all over 2x squared. If you are able to use a calculator and you know how to punch it in correctly, you could get the right answer. But if you don't, how would you proceed it without a calculator? Separate them. A great idea. Okay, when you see something so crazy like this, I would totally separate them. Okay, over 2x squared plus 2 sine, limits I should say. Limit as x approaches infinity of 2 sine of x divided by 2x squared. Now what?
Cancel off the x.
Okay, so that one's one of that. Then I have one x left.
And a 2.
And then the 2. Good eye. Okay. So I'm left with limits as x approaches positive infinity of sine of x over 2x, right, y'all? Plus limits as x approaches infinity of sine of x over x squared. Yeah, so far so good? Now what?
You do quotient.
Would you agree that there's a 2 in the bottom?
Yeah.
Would it be would it be the same as if I were to write it like this, like 1/2 times sine of x over x? Would that be the same?
Yeah.
How about the other side? Would it be the same if I were to write, can you see there's an x squared in the bottom? What if I write 1 over x times sine x over x? Are those all equivalent? Okay. Now, what do we know about a constant multiple? I can take it out, right? Find the limits first. Okay. I can take that out, find the limits first, and then multiply it back in. So, bless you. Okay, so find the limits first. Do we know what that is?
1.
Are you sure it's 1?
0.
Yeah. Right? Okay. Now, how about over here? Don't I have the same thing? Okay, so this is the limit as x approaches infinity of 1 over x times the limit as x approaches infinity of sine x over x, right, y'all? Okay, so I'm going to highlight these things right here. What and what? Okay. What do those things give us? 0. 0 times anything is? 0. I don't even care what this is, right? In the moment that's 0, do I care what that is? No, technically, that's still what? What's the limit of 1 over x as x approaches infinity? Is 0. You're right. So this is really 1/2 times 0 plus 0 times 0, which is 0. That's what the calculator said is 0. Okay. Now the right side, you're gonna do the same thing, but can I start at the bottom? Because all the properties are the same. Would you guys agree? So can I just use like this last step on the bottom here, like where okay. So this last step, all I'm gonna do is substitute instead of positive infinity. Can I just substitute with negative infinity? Yeah. So, because all the properties of that, it's exactly the same. Okay, so the limit as x approaches negative infinity, I'm gonna have a 1/2 times sine of x over x plus limit as x approaches negative infinity of 1/2 times, not 1/2, 1 over x times sine of x over x. Would this still give us 0, guys? Yeah, would that still give us 0?
Yeah.
1 divided by a million? Is that still creeping closer and closer to 0? For sure. Okay. This is still 0. Well, 0 times 1/2 is still 0. So all of that is still 0. So we're going to end up with what? 0. Now I didn't ask for an HA, but if I were to ask for an HA, what would you give me? Y equals 0. Okay. Therefore, HA, if I ask for it, y equals to 0. So that's your HA theorem. Let's move on to vertical asymptote. What was it in algebra 2? We have this, right? Yeah, where the denominator can be 0, or if it cancels, it creates a hole. Okay. Okay, but we're only talking about vertical asymptote for now. We'll deal with holes later. Vertical asymptote theorem said, if you are giving a limit of a function f of x, and as x approaches to some number, let's call it a from the right, and if it equals to either a positive or negative infinity, okay? Or if you are approaching a from the left of some function equals to plus or minus infinity, then you have a VA. Then your VA is at x equals 2a. So can you see this kind of flipping the HA a little bit? So the HA says it has to equal to a constant. This one is says equal to infinity. Okay. All right. From memory, do you know what example 4 graphs looks like? If not, use your calculator. If you don't know from memory what that looks like, can you punch in your calculator x divided by x minus 2? What does that look like? So your calculator says is there an asymptote? At where? 2. There's a horizontal asymptote here. Does it look like this?
Yep.
Okay. So here's what it's saying. So it says here, use graphs and tables to find the limits as x approaches to from what direction? From the left, right? Is that plus or minus on your paper? Minus. Okay, so minus. So from the left. X approaches to from the left. What's your answer? Coming from the left. What's the answer? X approaches to from the left. What's your height? Thank you. I don't have a particular height, right? It goes down forever. So the closer you are to -2 from the left is negative infinity. Would that qualify as a VA? Yeah. Okay. X approaches over here 2 from the left. It equals a negative infinity. That totally works. Okay. How about if I ask you? Oh, it rains. How about if I ask you x approaches 2 from the right? What's your final answer in that one?
Positive infinity.
Yeah, okay. So this one, guys, limits as x approaches 2 from the left of x divided by x minus 2. This we said is negative infinity. Limit, it didn't ask in your notes, but I'm going to add it on, is, what if it's coming from the right? One more time, Alexandra.
Positive.
Positive infinity. Therefore, if I ask for VA, what would you say? Do you have a VA? X equals to 2. It says 11 o'clock. Did it lie, Anthony? It's the government?
Wow.
I know the government is lying about something. Is there a horizontal asymptote? Is there a horizontal asymptote?
Yeah, it's at 1. I just knew. Okay, good question. Why did I graph out the horizontal asymptote being 1? Well, number 1, your calculate should show a little bit. Doesn't your calculate show a little bit? Okay. If you don't remember from algebra 2, when you HA from algebra 2, ready? HA from algebra 2. Remember we have y equals, what's the biggest term on the numerator? Well, for this one, you don't have a lot of choices. What's the biggest term on the numerator? What's the only term on the numerator? X, right? Divided by, on the bottom you have 2 terms, but remember you're only looking for the biggest one with the degree. What's the biggest term on the bottom? X. Okay, remember this in algebra 2? Can I reduce this?
1.
Yep, that's why I got 1. That's algebra 2. Now calculus. As the limit approaches, let's pick negative infinity. As x approaches negative infinity, what's y approaching?
1.
1, right? Let's look. as the limits approaching positive infinity, what's y approaching? 1. So therefore, HA is 1. Let's see. Okay, example 5. This is a review of algebra 2. Why don't you give me the vertical asymptote? Give me algebra 2 method. A, find the vertical asymptotes. Actually, there's only one. So write it in and confirm with your friend. If you don't remember, ask your friend.
All you do is you just, because you set the denominator.
We want to use it to make it. We want to make the denominator equal to 0. So when you're asking for the value is equal to -4, cancel it out. So yeah.
So algebra 2, how do you guys define the VA?
Oh, okay.
Perfect. That's exactly right. Okay. Take your denominator and set it equal to 0. That means 2x equals -4. That means your VA is at -2. Exactly. You know, calculus or not, if you already know how to find a certain method, or I'm sorry, a certain value using algebra 1, algebra 2, then go for it, okay? B, describe the behavior of the function to the left and right of your asymptote. Since you only have one, how would you do that? We can use limits. Okay? So limits as x approaches 2 from the left of your function, which is x squared minus 1 all over 2x plus 4. All right, let's work that out. And then limits as x approaches 2 from the right of x squared minus 1 all over 2x plus 4. This is what it's asking. Would you guys agree? All right.
Why would it like approaching 2 instead of -2?
Oh, good eye. Thank you, Amy. It's -2. Listen to Amy. -2 and -2. Thank you, Amy. Okay. Okay, can I substitute? No, because I just found that value by setting the denominator to 0, right?
Yeah.
Well, that's not going to do us any good. Now what? Can I factor and cancel? I can factor, but is it going to help me cancel? No.
Take out a 1.
You take out 2 in the bottom. It's still not going to help me, right? So now what? Find limits. I want to know, as I'm approaching -2 from the right, what's happening to my y value? Divide? What do you mean by that? Synthetic division? Or long division?
Could you plug in like numbers so it's like left and
Like nearby?
-3, -4?
Yeah, okay. If I'm getting closer and closer to
Please
negative
pardon the
8,
interruption, this is Mr. Morris. I just want to let you know, and you probably see it out there, we've got some rain moving through the area, so once the bell rings, please make your way to your next class as soon as possible, and we want everyone to stay out of the rain, so we keep everyone safe. So, work with us so we can make sure we can get to the rest of the day. Thank you very much.
Okay, so what you want to do is you want to pick a value nearby, okay? Because obviously you can't plug in -2. So what's the closest value you can get to the right of -2? -1.99999. Would you agree?
Yeah.
Okay. All right, so here you go. Mentally, I'm going to spell it out first. Pick. X about -1.99999. You know what? Let's just hold this because I think you guys are distracted.